Hi everyone. Welcome to lesson 20, where we're going to talk a little bit about statistical bias and misleading graphs that you might see in your everyday life. So this is not a complete lesson on statistics by any stretch. Statistics is a giant field with lots to learn. So far, we've already covered averages and variation. So you should now be very comfortable with thinking about the mean, median, mode, and the weighted mean to calculate course grades. So you should know 4 averages, or 4 ways to determine the central tendency of a data set. And you should know 2 or 3 ways to calculate the variation of a data set, which means how spread out the points are in a given data set. So you should know how to find the range of a data set, you should know how to find the standard deviation, and you should know how to find the interquartile range, which is Q3 minus Q1. So you know roughly how to describe 2 important features of any data set. You know how to talk about the center of the set, and you know how to talk about how spread out the points are. So we're going to talk in this video about bar graphs and pie charts and how those 2 graphs can be misleading. I'm focusing on those 2 because those are the 2 most common graphs I see in my everyday life. I see them in social media, I see them in the news, I see them in billboards, I see them in commercials, people trying to, sell me something or convince me to do something. So we're going to focus on those 2 graphs and how they can be misleading, and then we're going to talk about statistical bias when you hear a statistical claim in your everyday life, such as in social media or in a commercial or in the news. So graphs are really important because you know how they say a picture is worth 1,000 words, and that's because our minds can interpret visual information much more quickly than they can determine other information, such as words or listening verbally to somebody or reading words. Therefore, it's possible to mislead people by presenting images that distort data or images that hide critical information. This can be done purposefully or unintentionally. So in order to be an informed consumer and citizen, we must pay deliberate attention to the images we see and analyze them critically. So let's start with bar graphs. If a bar graph does not start at 0, that is cause for concern. So that means we should think about what we're looking at, because the changes in the bar graph, in the bars, can appear very drastic if the graph does not start at 0. In addition to that, you should always examine the scales very carefully before you think about what the data means. So if you don't understand what the scales are on the graph, then you don't have any clue what the data means. And then that's kind of what this says here. Ensure you know what the scale is measuring. So you should make sure you know what the scale is, like make sure you can clearly read the numbers on the scale, but then you should also know what those numbers represent. So all of these things are important when trying to understand bar graphs and interpret them. Okay, so here's the first example where the changes look drastic between these bars. Like this bar looks like it's 1/3 of the height of this bar, right? So in other words, from 2009 up to, halfway to 2010, it looks like we have doubled the amount of people on welfare. Now, did we? It looks like we've more than doubled, right? It looks like triple to me. So did we though? Those changes look drastic because if you look right here, the starting value is 94 million people. It's not 0 people. So if the starting value here was 0 people, all these bars would look roughly the same height, because the difference between 94 million, 96 million, 98 million, 100 million, even 106 million, that is not a huge difference there. So there's different ways that if somebody presents this bar graph to you, I could present you the same information, but I could make all the bars look exactly the same height by making the scale start at 0 and by changing how this scales. Instead of going up by 2 million every interval, I could go up by 10 million, and then all of these bars would look exactly the same height. So that's why it's really important to understand what you're looking at and to not jump to immediate conclusions. Your conclusion might still be correct. Like maybe you look at this and you say, oh my goodness, there's a lot of people on welfare, so we need to do something. That could still be a valid conclusion, but you need to understand what these numbers mean and what this scale means, and don't let this increasing design fool you into thinking that this is a dire problem in 2010 and maybe it wasn't in 2009. To me, it looks like it was a problem in 2009 and still a problem in 2010, and we should address it and help, right? So another way of thinking about this is from 2009 to 2010, we're talking about a change of 10 million people. Is that a big deal? And I can tell you that the same data, while being truthful, I can tell you the same fact two different ways. I can say this is an increase of 10 million people on welfare, or because there are roughly 330 million people in the United States, I can say, the number of people on welfare increased by 3%. So those are the same facts, by the way, but does one sway you to think that this is a bigger problem than me saying it another way? So if I said the number of people on welfare increased by 10 million, as opposed to saying the number of people on welfare increased by 3%, does one make it sound more drastic than the other when they're really both the same fact? So these are things to consider, because these are ways that people will either intentionally or unintentionally lead you to reach a certain conclusion, like one that they might want you to reach. And everybody does this. I'm guilty of doing this too, because I have my own bias, right? So we all have biases. So just be aware that there are different ways to present the same facts. Let's look at this example. The graphs below show what Americans in the top income tax bracket would pay if the Bush tax cuts expired on January 1st, 2013. So this was several years ago. Which graph is more accurate? So if it were me thinking about this, I would say the graph on the right is more accurate, because the graph on the left looks like someone is trying to convince me that we should not let the Bush tax cuts expire because these people are going to pay 4 times more what they currently pay. Or, it looks like this is quadruple what they're paying now. But if you look at the scale, they'd be paying 35% in taxes versus 39.6%. So now when I say it with the actual numbers, it doesn't sound like it's that big of a difference to me. So this looks like a more accurate depiction of what would happen when the Bush tax cuts expire on January 1st, 2013. Let's try another one. Which graph below is more accurate for depicting the percent change in gas prices over the years? And I would again say the graph on the right looks like a more accurate depiction of gas prices. On the left, it looks like the price of gas is so volatile that it's doubling, and then it looks like it's dropping down to almost being free, and then it's like quadrupling or more than that, right? And then it's almost doubling again. It looks like over here that the prices are so volatile and that there's such a drastic change, when really all of these prices are roughly in between $2 and $3. Roughly, right? I know this one is below $2, but it's still, it's higher than $1.75. So it's maybe $1.80 per gallon. So this graph makes it look like the price of gas is roughly all somewhere in between $2 and $3 over the years. And I would think that that's more accurate. But maybe I would scale this a little bit differently. I might scale this by $1 instead of by $2, just so we could really see that the price of gas fluctuated between $2 and $3, and it seems to have remained steady there between 2007 and 2013. Okay, so those are bar graphs. So you have to pay attention to the scale, make sure you understand what the scale is measuring, and pay attention to see if the graph starts at 0. It doesn't have to start at 0, but your eye should immediately look there to see if it does start at 0. Because if not, the bars can look drastically, like what we saw here, the bars can look drastically different from one another when really they might be pretty close. So pie charts have to add up to 100%. So there's a reason why you put data in a pie chart. It is to show some kind of complete view of data that add up to exactly 100%. If participants can select more than one answer for whatever question you're asking them that you're showing the results in this pie chart, So if participants can select more than one answer, then the data is going to add up to more than 100% because people were allowed to choose more than one possible answer. It doesn't matter how many people or items are being studied in whatever question you're asking them. So here's a picture that was on the news. It's online now, where Fox News was saying back in 2012, it looks like these are the percentage of people who would back Sarah Palin, who would back Mitt Romney, and who would back Mike Huckabee. And so this was their pie chart. Does this pie chart make sense to you? It doesn't make sense to me. If you add up these percentages, they're more than 100%. This is like 60, and 60 is 120, plus 70 is 190. This is 193%. That doesn't make sense. This is a terrible diagram. You should not use a pie chart here. I'm not even sure what question they must have asked that you have percentages that add up to more than 100. They must have asked the question in such a way where respondents could choose more than one answer. For instance, if I asked, which candidate would you be willing to support? And then it was like a checklist, then you could select more than one answer. So for instance, maybe somebody could pick, I would back Palin and Romney, but I wouldn't back Mike Huckabee or something like that. So then you would pick two of them. But if I ask something like, which candidate is your favorite, then there should only be one answer, and then a pie chart would have been appropriate. So something happened here. Either they asked the question that they didn't intend to ask, and so then every person who responded gave more than one answer, and they still put the information in a pie chart, or they're just not sure how to correctly represent pie charts. I don't know. Fox News is a pretty big news organization, so I'm surprised that this slipped past so many people. You can't have a pie chart that looks like this because each of these sections makes it look like they're each at 33%. It looks like a third, and a third, right? And it's clearly not. So that brings us back to thinking about when can you use a pie chart. You can only use a pie chart if, when you ask your survey question, the people who respond can only give one answer. That's when you can use a pie chart. So here's an example. If I said, what is your favorite fast food restaurant? And I asked our class, and we want to represent the class's answer with a pie chart. Can we do that? Can we represent the class's answers with a pie chart? Sure. So if we give some examples here, like let's say we have like McDonald's was somebody's favorite, then we have Chick-fil-A. I don't know how to spell Chick-fil-A. I think it's like that. Maybe we have Burger King. If it were me, I would pick Salad Works. That would be my favorite. I'm sure we'll have a bunch of Chick-fil-A because I think people really like Chick-fil-A. You might get, what else is in there? Maybe a Taco Bell as your favorite fast food. Maybe a Wendy's. Okay, so let's pretend 1, 2, 3, 4, 5, 6, 7, 8. I'll give 2 more. We'll do Chick-fil-A again, and then we'll do another Wendy's. Okay, so if this was our class, let's say we have a class of 10 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so let's pretend that this was our class and this was their answers. And we asked everybody, what's your favorite fast food restaurant? And here are their answers. Go ahead and try and represent this data with a pie chart. Okay, I just did it up here. So let me see if you can see this. I'll bring it closer. So there were 4 pretend students out of our class of 10 that like Chick-fil-A, so that's 40%. So I made that the biggest portion of this pie chart. Then 1 student liked McDonald's, 1 student liked Salad Works, 1 student liked Taco Bell, 1 student liked Burger King, and 2 students liked Wendy's. So this is not a perfect pie chart because these should all look roughly the same area, and they don't. This should look the next biggest, and this one should look the biggest. But this can be represented with a pie chart because if you notice, all of these add up to 100. So you have 40 plus 10 is 50, 60, 70, 80, 90, 100. It adds up to 100%. The reason why it adds up to 100% is because every respondent could only select one answer. That's the key with pie charts. If you look at example 3, if I said, which fast food restaurants have you eaten at in the past week? And then everybody gives their answer. So let's say, somebody said, I ate at Wendy's, and then I ate at Chick-fil-A. I don't even know if that's how you spell Chick-fil-A or not. I don't know if there's a C in there. Maybe there is. Maybe it's supposed to be like that. And then if somebody else said I ate at Burger King, and then I also ate at Taco Bell, and then I also ate at Chick-fil-A, right? And someone else could say I ate at Salad Works and Taco Bell and Chick-fil-A. I'm just putting a lot of Chick-fil-A because I know everybody loves Chick-fil-A. I don't actually, but I know lots of people do. And then the last one, let's say somebody said Arby's, and is there another fast food restaurant that I could think of? And we'll just go with Wendy's again. It doesn't matter. Okay, so this is 4 people. 1, 2, 3, 4. Let's pretend that that's 4 people. Okay, and let's put a Chick-fil-A again, just to really drive this point home. So you asked 4 people, what fast food restaurants have they eaten at in the past week? And these are their answers. So everybody has eaten at more than 2 restaurants in the past week. If you try and make a pie chart out of this data, so if I erase this, we'll try and do a pie chart with this data. Then what you'll notice, because everybody ate at Chick-fil-A, then what you'll already have is Chick-fil-A is going to end up being 100% of your pie chart because everybody ate there. So that will fill this whole circle. So when you go and you try and put Wendy's on here, which makes it look like half of them have eaten at Wendy's, then you're going to do something like this, and it's going to look really confusing because people could give more than one answer. So your data adds up to more than 100%, and I haven't even put all of that on here. That's just Chick-fil-A and Wendy's. And the reason why it adds up to more than 100% is because people could give more than one answer. So that's what you're looking at when you are trying to figure out if a pie chart makes sense. The first thing you should ask is, what data is this representing? And in order to figure out that, you might need to know what question were people asked. And then these are their answers represented in this pie chart. Okay, so just to make a note of that, drive that point home. You cannot give more than one answer and then represent that data with a pie chart. So if your participants could give more than one answer, like in this example, what would be a more appropriate chart would be a bar graph. So I'll erase this. And again, it doesn't matter how many people were participating, right? Like in that case, there were 4 people that I hypothetically surveyed. And it doesn't matter if there were 100 people. Having more people is not going to change the fact that if you can give more than one answer, a bar graph will be a better representation. So you could say the people who ate at Chick-fil-A, there were 4 of them. The people who ate at Wendy's, there were 2 of them, right? And you could represent this. And you can keep going. The people who ate at Salad Works, there was only 1. And the people who ate at Burger King, there was only 1. Or however many they were. I forgot what I wrote. Yeah, and I think I'm missing Taco Bell, so you could put Taco Bell on here too. And it would be 2 people ate there. There you go. That would be an appropriate representation if participants can give more than one answer for whatever question you're asking them. Okay. All right, so that was our brief little review of how graphs can be misleading. So we only focused on 2 graphs, pie charts and bar graphs. But hopefully now you are aware of what you should be considering whenever you see one of these graphs in real life. The last thing we're going to talk about is sampling. So when somebody wants to make a claim about anything, about the population, about high school students, about mothers, whatever, they will usually take a smaller sample of the kinds of people they're interested in, like a small sample of high school students in order to draw conclusions about all high school students. Or they'll take a small sample of mothers and then draw conclusions about all mothers. So that's usually what one way that statistics is used is to take sample data and use that data to infer some conclusion about the population of interest. An appropriate sample is usually at least 10% of the population, but that's not always possible for lots of reasons, for cost reasons, money, time, resources. People tend to not want to participate in surveys. How many surveys have you participated in? Do you get an email that says, hi, you've been selected to rate your Walmart experience in your past visit, and you're like, delete, right? So it's hard to even get people to participate in any research study. But if possible, if you could recruit at least 10% of your population of interest to participate in your study, that tends to be a more accurate sample than if you had less. That's not always true, though, because it depends on how your sample is selected. So we're going to talk about that now. If I want to know how freshmen at Stockton feel about math, and I survey our class, what is the population that I'm interested in? What's the sample? Approximately how big is the sample size? And so let's go through these questions now. So the population would be all freshmen at Stockton, because that's what I'm interested in. I want to know how freshmen at Stockton feel. That's like my research question. And so I survey the freshmen in my current class, let's say. So I know, depending on which class you're in right now, for me, you might not be freshmen. So you might not even be in my population. Okay, so again, it's not the population of the entire world. It's only the population that I'm interested in. What's the sample? The sample would be people who participated in this survey. So it would be a smaller number than all freshmen at Stockton. And that would be who I asked to participate and who says yes. How big is the population? I don't know, maybe 3,000 max, 3,000 freshmen at Stockton. How big is the sample size? It depends. How many of you are going to participate in my study here? So let's say 20 of you are probably going to participate. What kind of variable might I measure? So if I want to know how you feel about math, and I just say, how do you feel about math? That would be a qualitative variable, because I'm asking you to give an answer in words to describe your feelings. And would this be an accurate study? And I would say, no, it would not be an accurate study, because I want to know how all freshmen at Stockton feel about math, and I only surveyed you. And you, unfortunately, are not representative of all freshmen at Stockton. There are some freshmen who are not in a math class. There are some freshmen who are in calculus. I'm just, giving a rough idea of how varied the population is, right? So someone who's in calculus probably feels a little bit differently about math than somebody who's in an algebra class. Or maybe not, but probably. So sample bias, which is the main message I want you to take away from this second half of this lesson, would be using a non-representative sample, such as a convenience sample, like the example I just described, not a random sample, or having participants being paid, or not paying participants, or recruiting participants in a way that would be biased, right? So all of this is sample bias. So if you contact participants by phone, there is bias there because not everybody has a phone. So you're leaving out those people who are still in your population, but they wouldn't be represented in your sample because they don't have a phone, which is the way you contacted people. If you pay people, certain people are going to accept your invitation to participate because they want the money. And people who maybe don't need the money are not going to volunteer to be in your study. So there's bias there. So there's all kinds of bias. So pay attention to how people are recruited to participate in studies when you hear a claim. There are two types of sampling that we're going to talk about in this video, but there's lots of ways to sample. Okay, there's all kinds of ways. If you take a statistics class, you'll hear about them. So there's convenience sampling, which means that you select the people in your study based on who's convenient to you. So the example I gave where I want to know about all freshmen, and I just asked you guys for your opinion about math, that's a convenience sample because you're convenient to me. You're available to me. I can just send you an email right now, and you would be a convenience sample. Random sampling, which is a much better sampling technique than just using a convenience sample, involves choosing people such that every sample of the same size has an equal chance of being selected, and every individual in the sample size should also have an equal chance of being selected as part of that sample. So it's like two things. It's maybe a subtle difference there, but they both do have to be true. Every sample, say you want to take a sample of 20 people, every sample of 20 people has to have an equal chance of being your sample. And within that sample of 20 people, when you pick the 20 people from your population, every person has to have an equal chance of being selected. So that would be a random sample. And usually you use computers or calculators to tell you who's in your sample. So one way this could be done is if you wanted to sample 50 people out of the faculty members at Stockton, and there's 1,000 of us, you could number each faculty member, like assign every person's name a number, and then you ask a computer to randomly generate 50 numbers from 1 to 1,000. And then you go, so if the computer says, okay, your numbers are 2, 5, 50, you go find the person's name who's at 2, go find the person's name who's at 5, go find the person's name who's at 50, and those would be the people that are in your sample. You would invite them to participate. They might not all participate, but that's one way to generate a random sample. And random sampling, because every person in the population has an equal chance of being selected, it helps to get a variety of different people in your population so that you're doing your best to accurately represent the entire population. Okay, let's look at an example, a real life example. So CNN wants to determine the president's favorability in the upcoming election. So they conduct a news poll by asking viewers to text their answer to CNN's phone number. And they ask the question, how likely are you to vote for the president in the upcoming election? And they have answers on there, like very likely, likely, unlikely, and definitely not. So why does this involve sample bias? Like, what's wrong with their process here? Not what's wrong, but what's limiting about the way they're conducting this survey? So there's a couple things that I saw right off the bat. First, they're asking their own audience to answer this question. So that's already a biased sample, because I'm guessing that they want to know how the entire population of the United States feels about the president, but they're asking people who mainly watch CNN, which is going to be a left-leaning, liberal / maybe slightly independent audience. You're not going to get many Republicans watching CNN. You're not going to get many conservatives watching CNN. So the answers there are going to be biased for that reason. Another reason is not everybody has a phone number or a cell phone that they can text, right? So somebody might have like a land line phone where you can't text on it. Or somebody might not have the money to pay for sending text messages. So they're going to be very unlikely to send a text to CNN to answer this question. So there's two reasons why it involves bias. They have a biased sample to begin with. It's a non-representative sample of their population. And two, they're asking people to text their answers, and not everybody has a phone, so they're leaving out some critical people who are in the population. So another non-representative sample. Okay, so here's our summary. I know we covered just a little bit today, but it feels like we covered a lot. So if you have to take a statistics class, you will cover way more than this, but this is just a good snippet, a good preview of what statistics is like. So always be skeptical when you interpret statistical information. When you see graphs, ask yourself, what do the variables mean? Can I read the scale? Like, do you actually know what the numbers are? And do you actually know what the numbers mean? Does the bar graph start at 0 if it's a bar graph? If it's a pie chart, is it an appropriate pie chart? In other words, were people allowed to give more than one answer? If so, pie chart is not a good choice, because then the data will add up to more than 100%. Statistics involves inferring conclusions about a population based on claims regarding a sample, a smaller subset of the population. So if you're reading a statistical claim, like if somebody said that, if you're pregnant, how does drinking alcohol while you're pregnant affect a child, right? So I would want to know like how they collected data, because we now know drinking alcohol while pregnant it can be very harmful on the baby, on the fetus. So how did they figure that out? Did they go ask pregnant women to drink alcohol and then like see what happens? I hope that's not what they did. But if so, how many pregnant women did they ask to participate in the study? Because if they only asked, say, 10, doesn't sound like a very trustworthy sample. But if they asked 500, now it sounds like, oh, okay, you had 500 people in that study. It sounds like you're closer to trying to represent the entire population. It sounds like a more trustworthy study. Maybe, depending on how the sample was selected. Okay, so here we go. How do you know that the sample is representative of the population? These are things that you need to know. You need to know the sample size, like I just said. You need to know how many people were invited and how many people accepted participation into the study. The larger the sample size, generally speaking, the more accurate the results. We need to know the sampling procedure. Like, how did you ask people to participate? Was it done in some biased way? Did you ask people, by calling them? Because most people are not going to answer a phone number that they don't recognize. So that's introducing a bias into the study. It might be a bias that we can't control, right? Like there are just some things that are out of our control, but we need to know those to interpret the conclusions of whatever study we're reading. And we need to know critical information about the sample. So who are the individuals being studied? How exactly were they studied? What specifically was done to investigate the research question? So the next time you hear a research claim, like in the news or on social media, or even, just walking out in a town or something, when you hear somebody say anything about a statistical claim, like, oh, did you know you're more likely to die on the car ride to the airport than in a plane? You should be skeptical as soon as you hear a claim like that. And all of these questions should come to mind. How did they figure that out? How many people participated in the study? How were they recruited? Was it a biased sample? How big was the sample, right? What exact question did you ask people to figure this out? Or what exactly did you do, etc.? All these questions should come to your mind. So I'm not saying you shouldn't trust what you hear, but you should always start from a place of skepticism. And then you ask all those critical questions. And once they're answered, now you can interpret the data knowing the limitations that exist around however this data was collected. I hope that this helps you moving forward in your everyday life. And if you have to take any kind of stats class, I hope that this prepares you for the kind of stuff that you will study.